we are going to discuss the magnetic field of Earth. Actually, to know the magnetic field due to Earth, that is Earth's magnetic field, we have to define three quantities. We have to define three quantities, and that are called element of Earth's magnetic field or Earth's magnetism. Before that, we are going to define some terms. Already we have defined geographic axis, an imaginary line joining the geographic north pole and the geographic south pole of the Earth. That is this. Ncert is the geographic axis. The line joining the magnetic poles, that is Nm and Sm, is called the magnetic axis. This is magnetic axis, this is geographic axis. Geographic axis, this is called magnetic axis. And geographic axis and magnetic axis do not coincide with each other, because magnetic north pole do not coincide with the geographic north pole, magnetic south pole do not coincide with the geographic south pole. That's why geographic axis and magnetic axis do not coincide with each other. The magnetic axis makes an angle about 11.3 degree with the geographic axis. Now, what is geographic meridian? It is a vertical plane. It is a vertical plane which passes through the geographic axis. Which passes through the geographic axis. That means you can say this is one plane. Actually, you get many planes. At different places you have the geographic plane or geographic meridian. Now, this is one. Now, what is magnetic meridian? It is also a vertical plane which passes through the magnetic axis. Magnetic axis, right? You can say this as geographic equator and this as magnetic equator. This is our magnetic equator. This is geographic equator. Since geographic axis do not coincide with the magnetic axis, therefore magnetic equator also do not coincide with the geographic equator. Now, the magnetic field due to Earth's magnetism has both magnitude and direction. The magnitude and direction of the magnetic field of the Earth at a place is completely or are completely given by three quantities known as magnetic elements. We have already told you. These are magnetic declination, second is magnetic inclination or dip, and third is horizontal component of magnetic field of the Earth. Number one, magnetic declination. This is denoted by D or theta. D for declination and theta. Magnetic inclination. This is denoted by I or delta. And third is horizontal component. These three are known as magnetic elements. These are known as magnetic elements. Now, first we start our discussion with the magnetic declination. What is magnetic declination? A magnetic needle which is free to swing horizontally lie in the magnetic meridian, that is its north pole of the magnetic needle points towards the magnetic north pole of earth, that is towards NM, and its south pole directs towards the magnetic south pole of the earth. If a magnetic needle is free to swing horizontally, then it lies in the magnetic meridian, and the north pole of the needle points towards the magnetic north pole, and south pole of the magnetic needle points towards the magnetic south pole. Since the line joining the magnetic poles, that is the magnetic axis, is tilted with respect to our geographic axis. Our geographic axis, that is geographic axis of the earth. The magnetic meridian at any point makes an angle with the geographic meridian. Right? At any point, magnetic meridian makes an angle with the geographic meridian. The angle between geographic meridian and the magnetic meridian. The angle between the geographic meridian and the magnetic meridian at a place is defined as the magnetic declination or simply declination. That means, see here, at this position, you can say the angle between this magnetic meridian and this geographic meridian. Between those two is the declination. Now, the angle between the geographic meridian and magnetic meridian at a point is known as the declination, and it is defined by d or theta. The declination is greater at higher latitudes and smaller near the equator. The declination in India is small. Its value at Delhi is 0 degree 41 minute east, and at Mumbai it is 0 degree 58 minute west. And from here you can say that east means its magnetic meridian is 41 minute east or right from the geographic meridian. Clear? 41 minute east means its magnetic meridian makes an angle 41 minute to the geographic meridian, and magnetic meridian is at the right of the geographic meridian. Now, what is magnetic inclination? If a magnetic needle is perfectly balanced about a horizontal axis so that it can swing in a plane of magnetic meridian. It can swing in a plane of magnetic meridian. The needle would make an angle with the horizon. That means, if this is our magnetic needle, just hang it from its middle position of its moment of inertia, center of moment, from its center of moment. Then this axis will make an angle with the horizontal. That means it will be not horizontal at each and every point of the earth's surface. From here, at this point, at Raghunathpur, it will make like this. See here. This is our horizontal. This is our horizontal and this is the magnetic needle. Its north pole is in the downward direction from the horizontal, and the angle, this angle, now see here, this angle, this is the horizontal and this is the magnetic needle. The angle made by the magnetic axis or axis of the magnetic needle with the horizontal is the magnetic inclination. The angle between the direction of the total intensity of magnetic field of earth and horizontal line is the magnetic inclination. See here, if magnetic needle is in this direction, that means this is the direction of the magnetic field of the earth, right? And if this is our horizontal direction, then the angle between these two is the magnetic inclination. Do you get it or not?
Yes, sir.
The angle between direction of the total intensity of magnetic field of earth and a horizontal line in magnetic meridian is known as magnetic inclination or magnetic dip, which is denoted by I or delta. Dip is the angle that the total magnetic field of the earth makes with the surface of the earth. In most of the northern hemisphere, the north pole of the dip needle tilts downward, and in the southern hemisphere, its south pole of the dip tilts in the downward, right? In the northern hemisphere, north pole will be going downward direction, and in the southern hemisphere, south pole will be going in the downward direction. Writing inclination at magnetic equator. 0, because its north pole is attracted by the north pole of earth, and south pole of the magnetic needle attracted by the south pole of the earth, right? South pole of the earth's magnetism, and the two forces are same, so it will be horizontal. There will be no angle between the magnetic meridian and the axis of the magnetic needle, right? And what will be the magnetic inclination at poles?
90
It will be 90 degree, because see here, if we place a magnetic needle, then it will be like this. This is attracted by this pole, so it will be like this. Angle is 90 degree. Similarly, here also it will be like this. South pole of the magnetic needle is attracted by the south pole of the earth's magnetism. It will be 90 degree. This is our geographic north, and this is our geographic south. Then this plane, this is another plane, this is a plane, right? This plane is our geographic meridian. This is our geographic meridian, right? And if this is our NM, and similarly here SM also. And This is NM. Then this plane is our magnetic meridian.
Yes, sir.
Okay. Now let us say this is our geographic meridian and this is magnetic meridian. Okay.
Yes, sir.
Then this is our geographic meridian, this is magnetic meridian. Then this angle is what? What is the angle? The angle between the magnetic meridian and geographic meridian is denoted by declination. It is our declination, right? This angle is declination. Now, if a magnetic needle is placed here, then it will be like this. It will be like this, right? See here, this is magnetic meridian. It will be like this. Is it clear to you?
Yes, sir.
Its north pole is tilted downward. That means the intensity of Earth's magnetic field is along this direction. Clear? Now, this is our I. I means intensity of magnetic field of Earth. And this, see here, this angle, this is the horizontal and this is our what? Field direction. The angle between these two is called the magnetic inclination. That means this is our magnetic inclination and this is our magnetic declination. This is I, intensity of the magnetic field due to Earth, and this magnetic field can be divided into two parts. One is called horizontal component, that is its component along the horizontal or along the what we can say along the horizontal direction in magnetic meridian. The component of Earth's magnetic field along the horizontal direction in the magnetic meridian is called H. That means if this is I, that means this is H, and the vertical component is called V. That is vertical component of Earth's magnetic field. Rather, this can be written as H, or you may also write this as BH, and this is BV. Now, you can write BH equals to I cos delta and BV equals to I sin delta. What is BH? BH is the component of total intensity of magnetic field of Earth in the horizontal direction in magnetic meridian. Just remember that thing, in magnetic meridian, not in the geographic meridian. Clear? Now what will be the horizontal component of Earth's magnetic field in the geographic meridian? This BH dash. This is the geographic meridian, right? BH dash will be equal to BH cos of theta. But vertical component remains the same because vertical direction remains the same. Is it clear? This is the vertical direction, right? Now this can be divided into two parts. One is along this direction, another is along this direction. Clear? Now this is the same. This is the vertical component of Earth's magnetic field in the magnetic meridian and also in the geographic meridian. But horizontal component of Earth's magnetic field in the magnetic meridian is denoted by BH, and horizontal component of Earth's magnetic field in the geographic meridian is along this direction, which is equal to the cos theta component of this. This is Do you get it?
Yes, sir.
Okay. And from here you can write two things. One is V by BH equals to I sin delta divided by I cos delta, that is tan delta. From here you can get the tan delta, or you may also write BV is equal to BH tan delta. And another thing you can write from here is that I square is equal to, or just write here, BH square plus BB square. BH square is equal to I square cos square delta, and BB square is equal to I square sin square delta. That means I square into cos square theta plus sin square delta, that is 1. That means I square. And from here you can write I is equal to root over BH square plus